Welcome to another lesson for Into Industrial Electronics. Now, it's taken me much longer than I expected to make these videos. So I'm first going to see how many views these videos get before I continue making content for Into Industrial Electronics. If you want to show your appreciation, hit that like button and watch those adverts from start to finish. Now, in Module 3, we'll be looking at Semi-Conductor Physics. The term matter is anything that occupies space and has mass. It can't be created nor destroyed, but transferred from one form of energy to another. And the examples are solids, gases, and liquids. For the term elements, it is a substance that cannot be reduced or changed and consists of atoms and molecules. A compound, if you look at this illustration, it is a combination of two or more elements. And here we have hydrogen and oxygen combined, and this will form the compound water. An atom has a positively charged nucleus with electrons revolving around it. A nucleus consists of protons and neutrons. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. For the term ionization, it is the process of losing or gaining electrons. A negative ion implies an atom gains an electron, and a positive ion implies that an atom loses an electron. Here we have an image for electron shell, and there are three outer layers. We have the K shell, the L shell, and M shell. Now, good conductors have at least one valence electron, insulators 8 valence electrons, and semiconductors 4 valence electrons. If we have a look at the K shell, we see that there are 2 orbiting electrons. For the L shell, it has 8 orbiting electrons, and the M shell has 18 orbiting electrons. For valence electrons hold atoms together by transferring electrons from one atom to another by sharing one or more pairs of electrons. For atomic bonds, we have ionic bonds where we combine a metal and a non-metal. In other words, one atom gives and the other gains. For covalent bonds, we have a combination of non-metal and non-metal. In other words, 2 atoms are sharing electrons. Conventional current is from positive to negative, and electron current flow is from negative to positive. For a crystal lattice structure, either silicon or germanium atoms form a covalent bond with each other. In other words, both silicon and germanium have 4 outer valence electrons to form a covalent bond. A semiconductor is a material whose conductivity lies in between that of conductors and insulators. An intrinsic semiconductor is a pure material with no impurities added. In intrinsic semiconductors, the number of excited electrons is equal to the number of holes. For an extrinsic semiconductor, extrinsic semiconductors are also called impurity semiconductors or doped semiconductors. When a pentavalent impurity is added to a pure semiconductor, an N-type semiconductor is obtained. When a trivalent impurity is added to a pure semiconductor, a P-type semiconductor is obtained. Thanks for watching this video. Don't forget to like and to share these videos. Thank you.